Hello my dear students, welcome back to Fluid Mechanics lecture series. I am your SumamMiss. My channel name is also SumamMiss. You can watch my videos on my channel. So if you found useful, please don't forget to like, share and comment. Your comments are highly valuable to me. The topic for today's discussion is pressure diagrams. What is pressure diagram? Pressure diagram is the graphical representation of variation of pressure intensity over an immersed surface. How it is prepared? It may be prepared by plotting the pressure intensity at various points on the surface. Now, how do we draw pressure diagram? Consider a horizontal plane of length L. It is at a distance of h from the free surface. So we have learned previously that intensity of the pressure at any point depends upon its position with respect to the free surface and specific weight of this liquid. Since the plane is horizontal, at every point is at equidistant from the free surface. So, based on the Pascal's law, intensity of the pressure is equal at all points. The pressure intensity is plotted. It is uniformly distributed at every point. So, the pressure diagram which represents this rectangle, that is A, B, C, D. So, area of this pressure diagram or area of this rectangle, that is equal to the total pressure force that is acting on this horizontal plane per unit width. So this can be explained in more detail by considering a vertical plane. So in the case of vertical plane, pressure intensity varies from point to point. So if we are moving from topmost point to bottommost point, pressure increases. Pressure increases linearly. H2 and H1 are the distance of bottommost and topmost point of this vertical plane with respect to the free surface. So corresponding pressures are P equal to rho g H1, that is the pressure at this point, and P equal to rho g H2, that is the pressure at this point. So if you are plotting the pressure diagram, pressure increases from rho g H1 to rho g H2 linearly. So if you are drawing the pressure intensity at various points, so pressure intensities varies linearly from rho g H1 to rho g H2. So if you are joining all these points by means of the straight line, then the trapezoid represented by A, B, C, D, that is the area of the pressure diagram. So if you are calculating the area of the pressure diagram, it is a trapezoid. So area of the pressure diagram equal to rho g H1 plus rho g H2 by 2 into H2 minus H1 represents the length of this vertical plane. Now based on the hydrostatic law, if you calculate the total pressure force that is acting on this vertical plane per unit width, then it is equal to P equal to rho g H bar equal to rho g into H2 minus H1 into 1 represents the area of this vertical plane per unit width multiplied with H bar, that is equal to H1 plus H2 by 2. So if you are comparing these two equations, they are equal. That means we can say that the area of the pressure diagram per unit width, that is equal to the total pressure force that is acting on this plane per unit width. Another thing is centroid of this pressure diagram, that is also coinciding with the center of pressure, that is the line of action of the total pressure force on this plane. Please try to prove this by considering the vertical plane and take it as a home assignment. Same principle we can apply in the case of inclined plane. So intensity of the pressure that is acting normal to this plane and this trapezoid ABCD, which represents the area of the pressure diagram. And as far as this principle is concerned, area of this pressure diagram or area of this trapezoid, which represents the total pressure force that is acting on this inclined plane per unit width. What is the use of this pressure diagram? The resultant force and the center pressure can be determined graphically for walls and other surfaces of constant vertical height, for which it is very convenient to calculate the horizontal force exerted per unit width. That is in the case of water holding structures like dam, tank, etc. This can be explained very clearly by considering a tank which is filled with a liquid of constant density rho up to the height h. Consider a point at a distance y with respect to the free surface. So based on the hydrostatic law, intensity of the pressure at this point equal to rho gy. So if you are calculating the total pressure force that is acting on this vertical wall that is equal to rho g into A into h bar. So if you are considering unit width, then it is equal to rho g into h into 1 into h by 2. So that is half into rho g into h square, which is acting through the center of pressure because it is a vertical plane. So center of pressure is not coinciding with the center of gravity. That is, it is not coinciding with h by 2. Since it is a vertical ball and pressure intensities varies when we move from top to bottom, the total pressure is not acting through the center of this wall, but it is acting through the center of pressure. So center of pressure equal to HP equal to h bar plus Ig by AH bar. So h bar is equal to h by 2. So if you are substituting, simplifying, you will get center of pressure equal to 2 by 3 h from the free surface. Now compare this calculation by drawing the pressure diagram. Since it is a free surface, pressure equal to 0 here, and it increases, and it is the maximum at the bottom. If you are drawing the pressure diagram, it is triangular shape. Since this surface is plane and it is vertical, pressure varies linearly, that is P equal to 0 at this point and P equal to maximum, that is rho gh at the bottom. So this triangle represents a pressure diagram, and area of this pressure diagram equal to half BC into AB, which is equal to total pressure force per unit width. So if you are calculating this area of the pressure diagram, that is equal to half BC into AB, that is half into rho gh into h, as same as this one, and centroid of this triangle, that is equal to 2h by 3 from this point A. So the total pressure P that is acting through the centroid of this pressure diagram ABC, that is 2 by 3 h from the point A. So this is the advantage of pressure diagram. That means area of the pressure diagram, which represents the total pressure force per unit width, and centroid of this pressure diagram, which represents the center of pressure. To conclude, we can say that the area of the pressure diagram, that is equal to the total pressure force per unit width, and centroid of the pressure diagram, that is coinciding with the center of pressure. In the case of inclined plane, if you are drawing the pressure diagram, then pressure diagram is normal to this plane. So since this plane is not extending to the free surface, pressure diagram is represented by the trapezoid ABCD, and center of pressure is coinciding with the center of gravity of this pressure diagram. It is also possible to draw the pressure diagrams in 3 dimensions for the surfaces of various shapes. So let us consider a triangular sluice gate. The top edge is at a distance of h from the free surface, whereas bottommost point of this gate is at a distance of h from the free surface. Since this edge is horizontal, the pressure here is uniformly distributed, so pressure diagram is rectangular here. Whereas if you are considering this edge, the pressure increases when we move down. So for this edge we are considering, the pressure diagram will be a trapezoid. So if we are drawing the intensity of the pressure at various points, then it will be normal to the surface. So its pressure diagram is represented like this. However, such diagrams do little more than provide assistance in visualizing the situation. Now let us explain this principle by solving a problem. Consider a closed tank that is rectangular in plan with the vertical sides 1.8 meter deep. So it is filled with water up to the height of 1.2 meter from the base, and above which it is filled with air with a pressure of 35 kilonewton per meter square. And the length of this wall is given as 3 meter. So it is asked to determine resultant force on the wall and height of the center pressure. So we can work out this problem by drawing the pressure diagram. So here air pressure that is transported uniformly over the whole of this vertical wall. So pressure force due to air can be represented by a rectangular diagram, that is ABCD. Since this wall is rectangular and this air pressure is distributed uniformly, pressure force due to air acts at mid height of the wall, that is 1.8 meter by 2. So water is available up to the height of 1.2 meter from the base. So water pressure is 0 here, and it is increasing to the maximum value at the bottom. So if you are drawing the pressure diagram for water, then it is equal to 0 at this point E corresponding to this free surface, and it increases to the maximum rho gh at the bottom. So pressure force due to water that is acting through the center of gravity of this triangle. So total pressure that is the summation of P air and P water, which is acting at a distance of x above the base. So we have to calculate the resultant force and the point of action of this resultant force. So we can utilize this pressure diagram for the calculation of this resultant force. So area of the pressure diagram that is equal to the pressure force per unit width. Since length of the wall is given as 3 meter, then the total pressure force due to air that is equal to P into AB, that is the pressure force per unit width, multiplied with the total length, that is equal to the total pressure force due to air, that is equal to 189 kilonewton. Since this wall is rectangular and air pressure is distributed uniformly, P air act at mid height of the wall, that is equal to 1.8 by 2, equal to 0.9 meter above the base. Similarly, total pressure force due to water can be calculated by calculating this area of this triangle. So area of this triangle represents the pressure force due to water per unit width multiplied with this length of the wall will give you the total pressure force due to water. If you want to calculate the pressure force due to water, then we have to find out this area of this triangle. So area of this triangle represents the pressure force exerted by water per unit width. So if you are interested to find out the total pressure force exerted by water per unit width, then we have to multiply that with the length. So half into rho gh into h will give you the area of this triangle multiplied with the length will give you the total pressure force exerted by water, that is equal to 21.19 kilonewton. So the point of action of P water that is coinciding with the centroid of this triangle, that is equal to h by 3 above the base. So we have to calculate the total resultant force, which is a summation of total pressure force due to air and total pressure force due to water. So P equal to P air plus P water, that is equal to 210.19 kilonewton, which is acting at a distance x above the base. So how will you calculate x? That is P into x equal to P air into 0.9 plus P water into 0.4. So x is equal to 0.85 meter above the base. Now let us discuss about the engineering application of hydrostatic force. Dam is a massive structure which we constructed across a river or stream for storing water. Upstream face of the dam is always in contact with the static mass of this water and it is always experience the pressure force. So based on the hydrostatic law, total pressure force can be calculated as rho g into ah bar, that is equal to half into rho g into h square, which is acting through center of pressure, that is 2/3 h from the free surface. By using the pressure diagram also we can calculate this. Pressure is equal to 0 here and it will be maximum at the bottom. So if you are drawing the pressure diagram, it will be like this. So area of the pressure diagram which represents the total pressure force per unit width. Area ABC represents the total pressure force per unit width, that is equal to half into rho gh square, and it acts through the center of gravity of this triangle, that is 2 by 3 h from A. So please remember, by using the pressure diagrams, it's very easy to calculate the resultant hydrostatic force and the point of application of the resultant hydrostatic force. That means area of the pressure diagram which is equal to the total pressure force per unit width and center of gravity of this pressure diagram which is coinciding with the center of pressure. Some of the common questions usually asked in competitive exams is regarding the stability of the dam. There are 4 points to be considered regarding the stability of the dam. So in addition of the pressure forces and weight of the dam, we have to consider the uplift force also. What is uplift force? It is an active force within both the foundation and the concrete structure itself. The pressure exists in cracks, pores and joints of the concrete and the interface of dam structure and the foundation, etc. The first case we are considering is the failure due to sliding. Pressure force due to water that is acting in one of the side and weight of the dam that is acting downward. If mu is the coefficient of friction that exists between this foundation and this base of the dam, so failure due to sliding can be prevented if mu w that is greater than P. Second case of failure is failure due to tension or compression. So normally dam is strong enough to resist compression, but it is weak in tension. In order to maintain the stability, the resultant of P and this W and this uplift force must cut the base within the middle third. Third case of failure, that is failure due to overturning. The horizontal force P tend to overturn the dam about the top, whereas weight of the dam that is acting down, that is tend to counteract this overturning effect. The fourth case is failure due to shear at the weakest section of the dam. Consider a section with the area A1 and P1 is the pressure force due to water above this section. If tau is the shear strength, so tau into A1 that is the shear force. So if tau into A1 is higher than this P1, P1 is the pressure force due to water above this section, then failure due to shear can be prevented. So these are the four cases that is influencing the stability of the dam. And these 4 points are normally asked in competitive exams. So please try to remember these facts. Now we comes to the end of the session. We had enough discussion regarding the use of pressure diagrams for the calculation of total pressure force per unit width and the center of pressure. By using the pressure diagram, resultant force and the center of pressure can be determined graphically for walls and other surfaces of constant vertical height. It's very convenient to calculate if you are using the pressure diagrams. For the time being, it is enough. Thank you. Awaiting your comments. Please don't forget to press the bell button to get the notification. In the next video, we are discussing the important problems in fluid statics.